Hello, good evening to all, and my name is Mohammed Sabir, and today I'm here. Basically, we are going to start a trust problem. Basically, this topic of the engineering mechanics. You also can say this topic of machine design element, design of machining element. And the thing is that before solving this problem, you can see that this is a trust problem basically. And when we say this structures becomes a truss. The definition of a truss is basically is what if the connections of the multiple element which is which is subjected to a uniaxial loading. Okay, this is a unique this e all element these all elements are subject to the universal loading. Uh, we uh, we cannot say exactly all elements are subject to uniaxial loading. The connections of the multiple elements. Whole elements are the 2D elements. Okay, and now come to the how to solve this type of problem, like what is the basic approach to solve this type of problem. Like when we design a truss, what thing we should keep in your mind. The first we try to find out the internal resistance forces of the individual elements, and then we go for the material selections and dimensions of the individual elements. The first part is comes under the first part comes under the problem of engineering mechanics, and the remaining two parts comes under the problem of machine designing. Okay, like strength of material machine designing problem. So first we initially first we focus on the force force analysis, how we find the internal forces. This is the basic, what is the basic approach to find the resistance forces. You can see that uh, first we make a video of this problem. You can see that this R and RB, the reaction forces which will be provided by a joint to the system, and here UDL is also be there, RA plus. You can see that remove the joints and make a. You simply can say when we solve a trust problem, basic intuition, the basic approach is what the first try to, and now look on that key how to, and the simple procedure is what key basically assume a whole system as a single element. Okay, the RA and RP is the reaction forces, and uh, here the UDL is there. Simply you can apply a Newton's first law on the system. RA plus RB is equal to PL. Okay, and you also take a moment about a point A. PL L plus L by 2 is equal to RB L by 2. It is not a typical, it's not an easy part, but thing is that you have to understanding about a Newton first law. The Newton, you can simply Newton for how to apply Newton first law. Basically, apply a, like sum of the all forces will be zero for a static system, because we are doing the static analysis. Okay, basically, and you also know for a static, for equilibrium conditions, moment should be zero about at a point. The PL L by 2, how this L by 2 comes to the picture. Basically, the effective point force due to the load is what is lie in the midpoint of the element. Okay, because of that we assume that the L is equal to L by 2, and it's simply RBL by 2. After calculating these, after doing calculations, we got PL by 2. Okay, now comes to the now comes to the now now we pick a one single joint and do this analysis. Here this RB there at a point A, this reaction force is RB. you know you know the simply you can see that, like this is the This is a basically joint. This is a basically joint. When we remove this when we remove the joint from a link, a reactions forces will be there. A reactions force will be there. That reaction force is what? Is a FAC and FEA. These two reaction forces, which will be provided by the link when we remove this, when we separate this, when we separate this joint from a link. This is a FEA and FAC. These two forces are the internal resistance forces. Okay, you know, all elements are the all elements are the 2D element. You can say 2D elements. So for equilibrium conditions, for 2D element, what will the equilibrium condition? The forces must be the forces must be in a uniaxial directions. Simply apply a Newton first law on this joint. FEA sine 45 is equal to PL by 2. FEA is equal to PL by root 2. And you can say the FEA is what? Here the is a sine component is balanced by this RB. FEA FEA is PL by root 2. FAC, the cos component, it's a balanced by a cos component, and FS is what? PL by 2. Okay, it's so simple. At a point C, you can look on that. At a point C, you know, we we have a we have a amount of what will be the resistance force at this link. By using equilibrium, you can find here EC resistance force in this link. In EC link is what? Zero. Is the resistance free link. Is the You can say there's no resistance force at here. Okay, there is no resistance force at here. You can say uh, you can say like this type of problems will come in the gate examinations. Now we do the simple analysis, like what will be the significance of that type of problem. Simply we understand that now now we come to the designing process. You know now how to find the dimensions of that particular element, and which materials we should use for the manufacturing of these elements. This is basically a very this problems comes under the machine design and strength of material. In next video we will discuss on that part, how to design truss. Okay, thank you, all the best.